Welcome. In this video, I'm going to teach you how to solve a general solution of a first-order linear differential equation. So let me put what a linear differential equation looks like. A linear differential equation looks like something like this: y prime plus p of x y equals q of x. Notice y prime can be thought of as dy dx, so you can replace that with that. But I'm going to leave it as y prime. So the way you do it is by multiplying by something called the integrating factor. The integrating factor looks like this. Ux is a function. It's a function of px. Ux equals e to the integral of px dx, where p and q, px and qx are continuous functions. So the first step is to multiply left side and right side by the integrating factor. So that will be y prime e px dx plus px y e px dx equal to qx e px dx. And if you notice, this here is a product. You can tell that this is the derivative of a product using the product rule. So the way you can replace the left side by this. It's like taking the derivative of a product. So the product is going to be equal to y e px dx, because notice, if you take the product, that will be y. The first term is y prime times the second function, and then the second term is y times the product times the derivative of this here, and that gives you this. Okay, so now the right side stays the same. E px dx. Then we integrate the left side and the right side with respect to dx. So notice, the left side we get y e to the px dx, because taking the integral of a derivative it just cancels. So you're just left with whatever is inside. And then the right side becomes qx e px dx plus a constant. And notice now we have solved for y, so the only thing left, so this is the general solution actually. Of course, if you're given a specific p and q, you need to integrate this. But this is the general solution. And you can really simplify it by noticing that this here is your integrating factor. This is your integrating factor. So this becomes y ux equal to qx ux, because this is the ux, dx plus c. And then if you want to solve for y, you just divide by ux, so that will be y of x is equal to 1 over u of x integrating qx ux dx plus c over ux. And this will be your final form. So notice the solution to this first order linear differential equation is as follows: this or this. This will be more easier to memorize, but yes, if you get to this point, you can get to this point. So thank you very much. Don't forget to subscribe, please.